Forest Products Lab, located in Madison. We've been around for 100 years. We started with the railroad ties, making them creosote treated, so instead of lasting 5 years, they're lasting 20 years and more. And I want you to, in the very last, you should have a handout. The very last slide on there gives a phone number and a web address. And if you get, anything that I tell you, you want to check on first, because there's all kinds of things that are almost good ideas, and you got to do it just right if you want to pursue that. So when we look at, and now this is mostly small diameter material, because that's the stuff we want to pull out of the forests to the ladder fuels that carry fire up into the canopy. If we are going to use that wood, we can see that it costs maybe $70 a ton to pull it out of the forest, and every 50 miles is another $10 to move that stuff. It's getting pretty expensive, and can they pay their way out of the forest is the issue. So we can see that posts and poles have come way down with the housing market drop. We can see that lumber is moderately low, but then it went up if you had suppressed growth. I'll show you a slide where we're taking some slower grown wood, and you can actually make 2x4s out of a 2x6. So that made it more valuable, but then again with our housing market problems, that has dropped back down. So there's all kinds of things that the wood can be used for, and most of you people probably have some feel for which way you want to go or you want to investigate. And I'll throw out a few things in this presentation. And like I said, we want to come back and work out all the bugs before you enter into some of these things, because there were some issues where some people jumped on something and they made a few mistakes. Years ago, there was a whole industry who were making wood foundations for homes, and that industry was gangbusters in Michigan, and it was a disaster in Wisconsin because a few contractors didn't follow the rules. It turns out it's a good idea in many instances. So we can see here, you have some logs. They cost more to harvest than they're worth. Same sort of thing, it can cost a little more to turn it into lumber, and that value could also be less than what they are worth. However, this value added, this is a company that is in Northern California. They took very slow-grown Douglas fir, and this stuff, some of these trees were more than 100 years old, and they were still only 4, 5, or 6 inches in diameter. So there's tons of knots, and it's a very pretty wood, and it's a whole new type of market. And the same sort of thing happened in Montana with some western larch. That was also an overlooked species, and it is paying its way out of the forest. Here's that same Douglas fir made into some furniture, and that's very attractive. So we can see there's all different types of things we can use the wood for. Unfortunately, energy is at the bottom end of that value stream as far as how many dollars we can get per ton. However, because the other things have been dropping, they're getting closer, and it's not such a bad deal anymore. Here's one thing: if we have some small diameter material and we put this in what we call as a hew saw, and there's some negotiations going on, and this particular machine may be coming back to the west. And here we can see the logs have to be sorted ahead of time, because this particular machine doesn't sort it, so you set up the knives ahead of time. It can get 20 logs per minute through this thing. And so now like I said, we have to have the right type of wood. I have little juvenile wood part of the tree. The very center is kind of flashing there, and the interesting thing about juvenile wood, it has a totally different cell structure. And if you ever went to the lumber yard and you bought a 2x4 or saw the 2x4s that were quite warped, if you look more closely, you may see that the side of that board that was warped up was the center of the tree, and that's where the cell structure is different. It's usually 5, 10, or 15 years of growth where that is going on. If you have a very suppressed growth tree, that 5, 10, or 15 years may be only a ½ inch, and then it's insignificant. So now we could have that juvenile wood on the side of your board, and it's not a problem. So that's why I was saying that older growth trees can still have a higher value. Older growth, what do I want to say there? Suppressed growth. So older trees that are still really tiny still have value. If you took a 6-inch ponderosa pine and ran through here, it's odds are you're going to have half your boards are going to be in bad shape, and ponderosa pine does have some strength issues, so that might not be an ideal situation. So that's someplace you've got this forest and you saw this and I want to put this in, and you had ponderosa pine, well, that would be a mistake. Here we are taking some ponderosa pine from larger trees, and with a very careful grading process, if you ever understood how beams, the stresses are going on in them, we have a long beam. There's a whole lot of, when there's pressure going down, there's a lot of stretching, and so there's tension on the bottom of that beam, and there's compression on the top, and there's not much happening in the middle. So you can use ponderosa pine easily all through that wood, and normally they would put like Douglas fir on the bottom to handle those big stresses on the bottom and on the top. With very carefully grading, you can find the very best pieces of ponderosa pine, set them aside, and then put them on the top and the bottom. So this is just an example of using some wood that typically might not have been good enough for beams, and now you were able to do it. The wood in the center can be quite poor quality. Finger jointing is another way to get around some defects. Always something to consider. Sometimes it's worth it. And here's a little diagram of finger joint coming together. That actually was very beautiful before we loaded it on here. It didn't have that red, but so we have a building that, or a demonstration house that we put on at the Forest Products Lab that we built 10 years ago, and it is an all-wood foundation and has all these other features. And every 2x4 on the interior walls is finger jointed, and every exterior board is a 2x6, and that's also finger jointed. And you can see there's different types of finger joints. For ours, because they were all in compression, there's not a whole lot of stress, this lousy finger joint works. If you're going to start putting more stresses and try and use them as a beam or something like that, you have to do everything right, because that finger joint can't fail. For the most part, it makes most sense just to do it where it's easy, studs. You can rip apart boards in a whole manner, lots of different ways, and then glue them back together, and then all the weaknesses of the boards are randomized in there, and so your new beam is going to be much stronger than an original piece of wood, unless you had a perfectly clear specimen, and perfectly clear specimens are getting harder to find nowadays. So if you have small wood, that's what you have to do. This is our picture from Wyoming. We had some nice trees over there, and what can you do with these sorts of things? Well, we can do anything, and it's just a matter of how much you want to put into it. But if you were to take these pieces and with a very careful saw follow the tree and make very small pieces like 2x2s and then glue them back together in various forms, these things actually have a pretty good strength. And in this case, these were made as headers. That's the area above a window or above a door or something. So they're not as strong as beams that are extending 10 feet, 20 feet. These are shorter distances, but this really lousy wood, they were dried in the 2x2 shape with weight on them, holding them in place, and then once they were dry, they maintained that. And then when you glue them together, odds are you're not going to have all those wanting to bend in the same direction, so they'll fight each other and it will stay straight. Normally, if you had one of those 2x2s and you had it perfectly straight when you pulled it out, and then it went through some wet, dry cycles, it would start to remember where it was. So these are things you have to be aware of if you're going to start using wood that has somewhat of a lesser quality. Here, this is a mat, and this mat is made by shredding the wood. So it's an interesting process, and we actually use a diaper machine, and diapers are kind of made, they weave cotton and other materials together, and if you have a whole nest of sticks of wood, and you take, and this is like crochet hooks, here's a pin, so you can see these are about 4-inch long spikes with a little hook on the top, and you have this big mat of all gnarled up material. You put those hooks through there and just weave it all together, and you run her through the machine. So this hook system is right in here. So in the beginning, you're just throwing all this stuff in there. It kind of mixes it up. And in the mixing place, we have some opportunities to do stuff. I'll show you some in some other slides. But anyways, by the time you've done that and you've pulled it tight and you roll it out, you have a nice roll, and there's all kinds of stuff you can do with that. For instance, you could use it as is or modify it chemically to use as a water filter. Wood has kind of a negative charge, and so if you have something with a positive charge, you can extract it. So something like phosphate, the phosphate ion is negative, so that's kind of a bad thing. It's the wrong thing to try and use wood. So if you're wanting to clean up for pollution, for lakes and stuff like that, wood isn't ready to do that, but you can treat it so that it will be. Wood, because it has a negative charge, now is all set for pulling metals. Metals have a positive charge. So if we have a mine and we've got iron, things that aren't so bad, or even things that are much nastier, the wood is ready to just suck this stuff up. I don't want to oversell this because we did have a professor that did oversell it, and he was talking about using this in a mine waste area where the fibers were soaked up the metal. Well, now when that, let's say it's iron, is on those fibers, now the whole system has somewhat of a positive charge, and now it could suck up phosphates. And so the promotion was that they were going to take these mine waste filters now and move them to the Adirondacks to clean up the phosphorus that was coming in. And of course, you don't want to put filters full of different types of metals and things in a pristine area to clean up the last little bit of phosphorus. So that was a ridiculous idea, and I don't want people to start thinking that you can do ridiculous things. In Seattle, they have some requirements for even parking lots to be clear. The water from the parking lot isn't supposed to go into the estuaries or into the whole watershed with the particulates from the parking lot. So they have a cute little filtering system. The water goes in, and this is kind of a flushing system, and basically the particulates filter out. Well, this whole it's just kind of like if you're a guy, you remember the old urinals that used to slowly fill up and then they would flush. Well, this does the same sort of thing, and particulates are filtered out. Well, if you had wood in there and it was the proper charge, it could also be removing some of the other things that are in there. So they've got these setups in Seattle where there's these canisters where there's 30 or 40 of them in a well at the corner of a parking lot, and then after the water goes in there, it heads on its way out, and it's cleaned tremendously. Another thing you can, so in those boxes, they could have that wood fiber. Another thing you can do is in that process, we could have been adding seed, we could have been adding fertilizer, we could be adding biochar, all kinds of stuff, and it could be rolled out as a mat for starting up in erosion control areas. And we did have some work with some space trips a long time ago where we actually impregnated them with seed, and it was a really nice foundation. So in the astronauts, all they needed to do was add the water, and they had this plate, and they could grow their lettuce and some other things, so it was kind of cute. So these are different types of using the fibers, putting them back together, and they work great for this type of erosion control. Stake them in, and you can then program how long you want that to last. And the program, of course, is by what species of wood you select. If you select cottonwood or aspen or some of these woods that touch the ground and they begin to rot, then we're going to have a really slow or a fast disappearance of that, and we want to have a seed crop that's going to be taking over right away. If you have a species that's going to be needing a nurse or the friends around or some support for a longer time, then of course you'd pick a species that's somewhat more durable. Again, you have to be careful. You're not going to use black walnut, even though that does last longer. Black walnut, of course, is toxic to all kinds of plants. You can, in that whole blending process, you could have some plastic. Now this could be from recycled milk jugs, or recycling makes the most sense because that would be a cheap product, hopefully. And then all you have is this same web, and you just take it and you just press it with some heat, and that plastic warms up, softens up, melts together, and then you let it cool a little bit, open up the presses, and in here we're making these little clipboards, and it's a really nice product. In fact, the product, that type of product is in many cars now. It's been about 15 years that you've had it in the German automobiles, as those dashboards and things. I'm moving on to a little slightly different type of composites. Instead of that mat, we're going to just mix stuff together. Wood composites we normally think of as particle board and fiberboard and all that stuff. Well, those are zillion-dollar operations. So my point is trying to get people interested, or helping people that are mom and pops or few small organizations. So we can't be making that sort of stuff. But if you know of a company who's making these plastic chairs or some plastic table or something like that, and they're buying this virgin plastic, and I don't know what they're paying, 90 cents a pound for it. If you can take wood flour and mix that with pellets and cut the cost way down, and wood, depending on how much you break it up, if you break it all the way down into a fine flour, it doesn't have a whole lot of strength. But if you break it into smaller chunks, you have a much stronger product. So you can have these chairs that now you sit on them and the backs flop and break. Because they're so flexible, by adding the wood, they can be considerably stronger. So this is the product that they normally would buy. You add it to this, mix it together, extrude it out, and now you've got a product that is this. And because it's roughly the same size as this can go right into their machine. So it goes right into their extruder. The issues again now, if you've got too much wood in there, it's a more of a brittle product. And then even though that chair is very strong, you get 3 people on there, but when the 4th person sits on it, it explodes. That's a problem. So you have to temper how stiff it is versus how strong it is. So here's some of the car parts that have been out there that have the wood plastic composite. Like I said, the back dash, the side panels, and your car doors and things, they're already out there. Here's some Juniper signs. This was made in a more of a crude form. It was just the recycled plastics. This is in Albuquerque, and the schools were collecting all the milk jugs. They brought those in, mixed it with the Juniper, and it's just kind of rolled around and rolled out. The whole operation is much more sophisticated now, but initially that was as basic as it was. Pressed it out, and you could have some stencils to make different types of signs. They had some definite advantages as far as porcupines not eating the older wooden signs were eaten by porcupines. These signs were somewhat less tasty. They stand up quite well to bullets. So there's various advantages there. This is something that really upset me. These shingles on this house, there are 7 shingles in a panel, 4-foot wide panel, that is that wood plastic composites. Now, we threw this wood and the plastic together. Normally these milk jugs and the sawdust together, it's roughly 50-50, would have, on the roof, would probably last 10 years. You put in ground up rocks. That's what pigments are. That's what makes paints last much longer than varnishes. It's something that doesn't break down with sunlight. By putting those ground up rocks in there, so it's a small portion, it's a fine powder, pigments, now we get a 50-year life out of this stuff. Well, it's got a lot of plastic in there, so it's got a burn problem. We put in fire retardants. We have a Class A fire rating. So now we've got a product that goes down in big sheets, so somebody can throw this down much faster than they would throw down regular wood shakes on a home. The problem was we set this company up in a small town in Wisconsin. The company was bought by a Wall Street firm, and it turned out that for them to make their money back in their investment, that it was going to take more than 5 years, so they canned the whole thing. So that really irritated me. That was, though, back in about 2004, when money was available and that sort of thing. Maybe today they wouldn't be so foolish, and somebody else could be setting up a process like this. So here's a little close-up. There's only one panel, and it's used over and over and over again, but you really don't see it if there's just some slight moving around. Now, you could make 2 or 3 different styles, and it would be even that much better. So they're able to throw this on the roof quite fast. There's also just plain extrusions. This is not the greatest market right now. It's kind of flooded, so we'll move on. This is mixing the wood fiber with cement to make a cementatious type thing. Normally, you see this hardy board and some of these other siding products, they stand up very well. There's not a whole lot of wood in it, though. It's only 10 or 15%. But we've set up some sound barriers, and they work quite well. You can make any kind of shape you want. This is almost like egg carton type technology. The same sort of thing. This, instead of mixing it with something cementatious or plastic, we mix it with rubber, and it's very flexible. And now there's been some requirements to the ADA business, so it's not fair that the kids in wheelchairs cannot play in the playgrounds, but we still want this stuff flexible. So by just mixing in a little bit of the rubberized material with that, it's very stable. The wheels don't dent it. We can drop a fake head in here, and it sucks up the impact very nicely, so it's a safe playground and something to think about. It's more expensive than normal playgrounds, but there might be niches for that market. It's kind of low right now because people don't have a whole lot of money for fixing up playgrounds. This is a shavings operation. I almost got a company who made pellets to, instead of making a pellet, just to break the wood into smaller pieces. And that operation, what can you do with that? Well, it turns out normal wood pellets in a cat litter will break into the sawdust, and it actually doesn't work that well. But if you keep it in this form, it's phenomenal as a cat litter. If you have a round log and you make it into its biggest rectangular shape from that, the best you can do, your new square is 1/3 as strong. And typically it's much worse. It might be 1/10 as strong. And there's all kinds of reasons for it. And so I'll just going to fly through this rather than explain each part. But anyways, there's a whole lot of variability. When it's round the log, we know the weakest one is this strong and the strongest one is this, so it's a really tight barrier. When you cut it into a square, you're going to have effects from the branches that were growing out of there. We've got some weak spots, the knots. So we have a much broader spectrum. That's just one example. Roundwood is pretty neat stuff. So we got these certified for, it's funny, every time you develop something new, you have the issue of can you really use it. So we got the certified as road barriers. Well, this was prettier too, so this will come out funny. This is just an example of engineering. If you've got one beam, so you're going to make a floor joist, let's say it can hold 100 pounds, you put a second beam underneath it, it can hold 200 pounds. If you just lock the ends so they can't slide past each other, it's, if we normally measure by how much stuff is springy, so it's how flexible it is. So it's not its strength, but its stiffness. It can be 10 times stiffer just by putting that on there. So now that can hold 1,000 pounds when one board only holds 100. So it's kind of neat. So there's all kinds of things you can do with the roundwood. Here's a structure we built on our lab site. It's our little picnic pavilion now. There's some things that have been expanded. Different connections is the most important thing. Roundwood is very strong, so the most important thing is how you hook them together. If you have one log coming, you drill a hole in it, 2-inch hole. You have the kids in the shop, high school, drill a hole in a piece of steel, and you drop that in there, and then you can thread a rod into there, and that will be a roundwood like this. And if you were to pull on this, this will hold 20,000 pounds before this log starts to break. This is just a 6-inch log, 20,000 pounds. You put these little hose clamps on here, now this 3/4-inch rod starts to stretch at 40,000 pounds. So that's what you like, a nice stretchy ductile failure. If you got these all lined up and one pops, if it was the break thing, then the whole catastrophically fail. If this had too much stress on it, then it would just stretch and then they'd all equalize out and it'd be a nice operation. So this is what's holding together the kiosks. It's holding together a big gymnasium up in Washington State. Different types of space frame structures. Here's a pavilion in Colorado. Very pretty. You can just put plates on here. It's not a sophisticated method, but people are happy with it. So they just have a bolt on, or screw on little plates, and then there's a big bolt that carries the load from one member to the other. So there's all kinds of roundwood structures. The guy who welds these together usually has to take medication. This is a structure in Montana, and it's quite pretty. So this costs a little more, but it's well worth it. Here's the Darby Library in Darby, Montana. The inside in the construction was looking like this, and after it was done, it looks like this. In this case, when there were tension members, they used rods instead of trying to make a connection at each end of a log. It's just, why bother doing that? If it's a compression, then it's the full steel, so it's quite simple. So we know this is going to be a tension component, and this is going to be a compression one. This kiosk was in Ogden. We went and looked for it yesterday at the new place it was supposed to be, and we found the foundation, so we don't know where that is, but this school system, or the city park system, has it. And here we are throwing that kiosk together. This is another one. This one's in Idaho. So just quick demonstrations of what you can do with roundwood. There's all kinds of connections. Each nail in here, when you have this is another type of connection. All you do is cut a slot in your log and drop in an 1/8" steel plate, and you can use nails that you shoot with a concrete gun. And with 22 shells, we call them powder-driven fasteners. One nail's worth 1,000 pounds. It has to bend on each side of that nail. It's kind of neat. So it's worth 1,000 pounds. You got to do it right, though. If you line them all up, you'll break the wood that way. If you line them all up this way, you'll break the wood that way. So this is stuff you have to do right. These people worked on some plates on the outside. Now the nail only bends once, so it's only worth 500 pounds. If you put if you have a bottom of a truss and you put a bolt through it, that doesn't have anywhere near the strength of just a little piece of wood, a key, because it's spread out over a long distance. So here's some beautiful connectors. This is the kiosk that's in Ogden someplace. This is the kiosk that's, see, it's all rough. I like this design better. This is the ones over in Heber. These were set up for the Olympics. And there's some options for, I'm done. This is Habitat for Humanity, and I've got some stuff here I can talk to anybody who wants to know about that, and then I just have some bridges. So 40 foot's easy if you need to put a bridge together. Want to ask some questions?
Yeah. We've got time for some questions, answers with Mark. Go ahead.
So Mark, I'm interested in the wood fiber mats. What kind of fiber preparation is required for them?
Kind of depends on what you want to use those final mats for, but for the most part, and they were using all kinds of stuff like jute, which had a really long fiber, and other things like that. But what were you thinking of? To make a board, or were you thinking of to?
Well, I did work with it with ag fibers in the past, and we used ag fibers because it was lower energy input, because otherwise you'd have to go through like an MDF fiberizing process, which then makes it large scale. So I was just intrigued about the wood element, if you were going to do RTM molding or something like that.
Yeah. Well, because there were so many different ways that we went, we'd have to sit down and talk to the scientists that were actually working with that to find out how much, the question was, how much effort or what did you do to those fibers when you were making those mats?
Another question from Mark? Go ahead.
Yeah, a lot of pieces that you showed on there, they really rely on good drying techniques. Are you helping people, or are you experienced with the drying for the fibers to get those to the right moisture content, or the small kilns that would be applicable for these gazebos and things like that?
Well, actually, the gazebos, that was an issue because they were 6-inch logs. It's basically a plan ahead process, and you might, in parts of the country, it might be as little as 1 year. But yeah, the actual kiln drying isn't done too much, so air drying is the way you want to go. You do have some issues with air drying. You can have pitch bleed and a few other things. But those are all things that we can solve. They're not outrageously difficult.
Has any of your work been with pinyon pine?
We've done a little bit, but because of the shape, the gnarliness and stuff like that, it's no good for whole pieces. But if you're going to be breaking stuff up, there's not a big issue there. Once you got down to the fiber size, and you're going to be making, if you're talking about mixing it with plastic or something like that, there's hardly a huge difference between species. Not nearly as much as how you fiberized it is more critical in that case.
Chemical composition of pinyon pine, it doesn't really matter what kind of plastic fiber.
It kind of depends on what you're using. With if it's milk jugs, that is a thermal plastic, so that melts and goes back together. It's not like it's a chemical bond, so it's not poisoned by the wood. That's one thing I forgot to mention. When you're working with cement, there are sugars in the wood that will actually poison the curing of cement. So people who have wood foundation or forms for making basements or whatever they're going to do with cement, frequently that cement on the surface is really poor quality the first time they use those forms because the sugars came out of the wood and wrecked the cement. So but it's a simple process basically of washing the wood to get the sugars out. And if you use a little bit of an alkali, so a high pH, you get those sugars out right away.
One last question, go ahead.
I was going to ask, what about wood fiber insulation? There doesn't seem to be any of that made in the U.S.
Well, we don't have the older, there was a lot of wood fiber in the past, and it was just kind of shredded up and used kind of like those mats and stuff there. But I wouldn't be surprised if a third of our insulation is wood now, but it's in the form of the shredded paper. And that works very well. It has huge advantages over things like as far as air filtration is much lower than the fiberglass. It has a few problems. If you put it in the walls, it'll settle, but we have solutions for that. That is commercial. Basically, it's just a little bit of spraying some adhesive in there, and the adhesive is just plain Elmer's glue. It's polyvinyl acetate. And when you spray it in the wall, it stays right in position and forever. So we're using it for insulation. But if you wanted to use wood sawdust for insulation, you probably want to fluff it up a little bit, but definitely it's a possibility. There's a lot of waste paper, though. That's where it's headed.
Mark will be around for the next couple of days, and he's presenting again tomorrow, so don't hesitate to approach him with questions. Thank you very much.